Welcome to the webinar. I'm joined by my colleague Alyssa Sullivan from TomTom and Matthew Dick from East View. Alyssa and I will actually be addressing you during this webinar. Matthew will be available for questions. The demonstration that we have for you in the middle of the presentation was put together by Matthew, reflecting the build of the product that Matthew's been a part of for the last year. At the bottom of this slide is a URL that you can go to and review information beyond what's covered in this webinar. And as Carolyn said, just please ask questions. My email address is peppered throughout this webinar so that you can ask now or later as you see fit. So I'm going to go ahead and start. Okay, the first two slides, I just introduce East View and TomTom. So East View Geospatial is located in Minneapolis. We're about 30 years old now. We have a sister company here that was started about 7 years before that called East View Information Services. EVG supplies geospatial source data from around the world. And source data including topographic, DEM data, navigation data, and vector basemap data like TomTom represents. We work with thousands actually of commercial and government publishers of geospatial data, from geological surveys, hydrographic agencies, national mapping agencies, and then a variety of commercial providers like TomTom or Maxar or other creators of geospatial content. We marry all of the source capabilities. I mean, really, we are a company. If someone wants to know if some mapping asset is available over anywhere in the world, that's really the answer that East View, or the question that East View answers. And over on the right, geospatial.com and shop.geospatial.com are another couple of URLs that you might want to look at now or later. That gives you a sense of the breadth of the geospatial data that we hold in-house or that we can procure. And then the final point is, married to all of this source data are pretty advanced geospatial production capabilities, whether it's SAR data, whether it's conflating, whether it's working with ArcGIS or other software, creating mil-spec mapping, which we get contracts for, a wide variety of capabilities in-house. And the TomTom relationship is one of the ones which we've been a part of for somewhere in the 13 to 14 years. They make, and TomTom's been around for over 30 years. They are based in Netherlands. They make an authoritative global base map, first and foremost, to support navigation and cars. Over the years, some of you may have had, in fact, a TomTom hardware device in your car before we had smartphones, before there were all these computers in cars. TomTom was one of the original creators of navigation-based data. So they have a very long track record of creating a world map. And Alyssa will get into how Orbis builds upon the legacy of great TomTom proprietary legacy data and takes it quite a bit further. And that's really the aim of this webinar, is to introduce you to Orbis Maps, which was introduced to the market only at the middle of last year. So it's not quite even a year old yet. East View made a sale to an Australian GeoInt customer that wanted a whole world data set in FGDB with vector tiles, with a lot of capabilities just to plug and play in their environment and quickly and efficiently use a product. And so we chose TomTom for that bid, and we won for two reasons. The Australians said that the Orbis Maps data was the most complete data, and that East View did the finest job of converting that PBF-based data file into an FGDB that was ready for them to exploit immediately. The webinar flow today will take us through what is TomTom Orbis Maps. Here's a couple more URLs. In fact, I've added the TomTom one so that you can get their information on Orbis Maps. And then Alyssa will talk quite a bit about how does TomTom through their Orbis product handle OpenStreetMap and Overture data. These are two very, very important additions to the TomTom proprietary data layer that they've built for decades. We'll go through about a 6-minute video demonstration. So we're not going to go through a live demonstration and fumble through that. We've canned that for you. I likely will not stop that along the way. I'll just let it play. So as you have questions, just please put them in the Zoom Q&A and we'll get to them. We'll show a couple of cartographic products that we've built here at East View using some of the underlying Global Vector Basemap Orbis data that we built for the Australians. And then we'll have questions and a conclusion. So the value proposition and the basic use cases, or the general use cases, we're actually going to get into some use case slides later that are very dense and speak to a whole bunch of different use cases. We have a mixed audience on this webinar, represented by what's in the gray box. We have some commercial entities, some non-government organizations, some government entities, and I believe actually we also have some academic institutions that are participating in this webinar. Typical use cases, visualization. And in fact, the product that you'll see demonstrated was built around a visualization use case. And then at the bottom, to enable also cartography. What that customer did not want was network analysis, geolocating, or logistics, but we've had other customers, and so the demonstration will go into all of that. And then the final point I want to make on here is Eastview is very used to dealing with all these different kinds of entities. So in the Australian case, they truly wanted the whole world. You may only have 100 square kilometers or slightly larger. You may have an area of interest that we can clip out and create something for you that really works as your vector base map for that custom area. And I think that's a key component of this. You don't have to buy everything. All right, so I am actually going to turn it now over to Alyssa, and I'll be driving the PowerPoint here, but she will be speaking.
It's great. Thank you so much. I hope everyone can hear me. So let's start with introducing Orbis Maps. And Rod did a fantastic job introducing the company. And while Orbis Maps has only been on the market for a year, we've really been working on this for many years internally. In 2022, TomTom set a new standard really by combining open and commercial sources. TomTom's approach, of course, we are not the first company to work with open data sources, but we've really been taking a unique approach to working with open data and OSM specifically. Our approach has been to really excite the mapping community. In many cases, we have been working with the existing OSM communities, and we've also been creating and establishing new open source communities so that we can really harness the full potential of not only working with fantastic proprietary sources and commercial sources, but also make sure that we're exciting and developing an open data community. And that's really what this is about. This is about exciting an entire new group of individuals that want to improve the map, that want to have a data standard. And with TomTom Orbis Maps, we've had to make a major shift in how we create our map. And when we look at the future, we want to make sure that we are future-proofing the way that we think of our value add and also the base map. And our base map can't be unique to TomTom. It really has to be this interoperable layer. And when we think about all of the millions of users out there that are contributing to an open data source such as OSM, or now when we speak of the other O name, Overture, we want to be talking about a common base map. So while TomTom has fantastic value add, and we have value add that comes in the shape of OSM data with our own specification, we're also talking about our Orbis data that is our proprietary data. But we want it all to be on the foundation of an interoperable map so that anyone that is adopting this interoperable map can utilize our base map with our value add, but they can also work with open data sources if they so choose to work with an Overture data or other open source. Everything is interoperable. But we want to take the pain away. And this is where Overture Map Foundation really came in. So you see that in the map data ecosystem, you have a lot of challenges because in the recent years, this is only sped up. You have multiple references and they're all working in isolation of one another. You have all these, all of these major players, they're all wanting and needing a strong map. But there is power when groups are coming together. And you're looking at the users here, 131 users, 131 million users. You have 4 billion users, nearly 120 million users, tens of millions of users for TomTom Map. When you think about all of that, you're not just thinking about the users, but you're also thinking about the feedback. You're thinking about the potential edits. You're thinking about all of the real-time map freshness, and also the high level of quality and self-cleansing that comes with all of these users. And for us, we wanted to be a part of Overture from the very beginning, and that's in 2022. And we were a part of that founding division. And that was within 2022, and actually it was established in December. And with that, that is the steering committee of Overture, and we have a schema. This is something that is difficult to work with OSM data. The trouble with OSM data is not that it is it's flexible, it's fantastic. You have the power of the community, you have billions of editors, but you do not have a common schema. So therefore, it is difficult, it is heavy, it is cumbersome. What TomTom wanted to do, and we did successfully with Orbis, and now with Overture, is we've established a common schema through working groups. And with data, we have a working group as well. And that's where we talk about how we can make certain open source features such as places, high-level admin areas like country, state level. And then, of course, what we're talking about as that base map of the interoperable, that's the transportation. And these are all task forces. And this is where all of the foundational members have a say on the direction of these groups and these big decisions. But things are happening very fast. We wouldn't consider this a consortium. We call this working groups, where members are getting together and they are working fast and making decisions in these task forces. Now, we talked about the pros and cons of all of these different isolated, proprietary, open. If it all comes together, and it has come together, this is where real magic can happen. A single reference map. And this is where you can move beyond conflation and pipeline problems. You can move to improved quality. You can move to weekly releases or even faster releases. You can start thinking about, how do I even build on top of my platform for maps to say, maybe we want to consider like what we have for our platform, but bring your own data. So we have a fast working system where we are taking in feedback, We are utilizing feedback. We are collaborating, but we also have the ability to look at a prospect or a customer's layer. We can house that. They could edit. We can edit for them. It's a way in which our platform can be a service as well as our products. And so when we look at Overture, people are a little bit confused sometimes about how Orbis and Overture differentiate. So with Overture, it is exactly how our product is delivered. So we have our road network, which is interoperable to Overture Basemap. It is the road network. There are similar splits on intersections. They're merged on other splits. We have stable IDs. This is something we call GERS IDs. And this is a way that in which you could utilize all other layers because it's a common ID standard. So not only stable ID, but it's a common ID and a common reference for all of these other layers. And in all of this, this is where we can say with a common base map, with a common standard, we're moving beyond just how do we blend all of the open and commercial sources together. We're going further. And this is how you can manage to have all of these use cases. And probably can't read this slide. That's okay. It's to say in red, these are all of the use cases for navigation and routing. And in navigation and routing, these are just all of the things that as a user, I would want to do. I would want to have turn by turn with legal routing. I would want to have routing to avoid certain truck restrictions. I would want to have major road with construction insights. And the same for that teal. This is to say, with Orbis Maps, all of the use cases are supported, but we're going even further. So we're not only saying, I want to find an address, I want to find a street, I want to go further to displaying other types of addresses on a map or displaying information that are searchable within an index. And then on the bottom, this is where we're going even further. And this is where the use cases are developing even more today. And this is advanced driving assistance. This is where we're talking about our high definition, our advanced driving. And so for this is the standard gradient, curvature, traffic signs, but going even further for Orbis on road classifications that were typically not supported by high definition or advanced driving content. So some of our use cases are going even further today, tomorrow. So some of the conversations that we hear, because we're listening to our prospects and our customers every day, and I wanted to have a couple slides here because I think people still have the feeling that we should treat OSM source differently. And I wanted to just remind people that our authoritative source supplier and our way of handling OSM is like any other source. However, we have additional checks for making sure that we are rejecting certain OSM content that does not meet our standards. And when we're building an authoritative map, we have a mechanism, and you'll see that on the next slides. We have a mechanism for vandalism protection. We are cleansing, we are normalizing, we have quarantining processes and things that we consider self-audit and self-cleansing when it comes to OSM data. But this is not unique to OSM data. We have always had regression checks. We've always had certain quality checks and standards for every source that TomTom would use. Now, because we're talking about such a widely used community resource, yes, we've had to be more strict on vandalism, and that's why we've created a unique quarantining process. And in this is more of a self-cleanse mechanism to ensure that we are not introducing unintentional errors. And this is my last slide, and this is something I'd like to leave you with, which is which kind of defines the full view of the compilation and assurance when we talk about open data. Because I think everyone understands TomTom products have always had strong authoritative commercial sources and our own proprietary data. And when we talk about a proprietary map, we know that there are pros and cons to this. And we know the pros and cons of an open data product. But here, this is where we have had to define a feature model because, again, open data sourcing does not have a feature model. This is where we have had to introduce a new spec, a new feature model. And with that, no matter the data, whether it's OSM or otherwise, it has to conform to our specification. And it has to be a uniform representation of this map feature so that our customers and prospects can use this map. The normalization, that will eliminate, again, complexities, any kind of issues. The conflation, again, we have a unique binding mechanism that takes value-added feature. Again, our OSM, we call this an OSM or Orbis value add and our own proprietary value add, which are bound together. Quarantining is a unique process in which we are holding and self-cleansing. And then, of course, all of our quality checks, thousands and thousands of quality checks and consistency checks, which enrich the data and ensure a high-quality product.
Well,
And
thank you so much. I know there'll be some questions.
Of course.
Alyssa. And I put this slide back up as really a transition for then the demo. Again, we don't expect you to read all of this. This will be, the whole PowerPoint will be available as a PDF after this. But as you are looking at this, think about your use cases. There's so many different people on this call or on this webinar. Quite a few different use cases. The TomTom Basemap and the East View production customization are really here to support every use case you see on this particular screen. So we work with Orbis, as I mentioned, and what do we specifically do to the data? We do a customized PBF data conversion into an FGDB. We create the schema and manage all the attribution. Depending on whether it's the globe or local, we optimize the zooming and the attribution and the features, so through generalization and other methods. And then we can get into cartographic and metadata services depending on the need of the client as well. So East View takes this ever-changing vector base map, and actually on a later slide, oh, bummer, I did have it on another slide. What I would like to say is East View also has other global or local vector base maps that can be conflated into this road network, a maritime global vector data set, DEM data, topographic data, geological data, aeronautical. So depending on what your needs are, this starts the Orbis Maps global vector base map or local vector base map starts the conversation, and we can add other things as well. So now when I click on this, we're going to go into about a 5-minute demonstration, and I'll just let it roll, and we'll come back to the PowerPoint in just a few minutes.
What you are seeing here is a global vector basemap that East View creates annually for a GeoInt customer. East View starts with the TomTom Orbis PBF file and transforms it into 4 separate geodatabases. Currently on screen is the global geodatabase. Additional scales, in order from small to large scale, are regional, local, and specialized. These can also be seen as feature groups in the table of contents on the left. The global, regional, and local scales are generalized. This includes dropping features or labels at certain scales and simplifying the geometry of line and polygon features. This allows for faster display at these smaller scales. I'll begin to zoom in, and as I do, we'll see additional features and labels appear, and you might notice changes in geometry. Also, as we hit certain scale thresholds, you will see the corresponding scale feature groups become active in the table of contents. Regional scale is now active. And heading right into local scale. And finally, we are now in specialized scale. Note that the focus of this project was visualization for use as a base map, as opposed to analysis. As such, the feature class attribute tables tend to have a smaller amount of attribute fields as needed to symbolize feature types. For this point of interest, the kind field in the attribute table was all that was needed for symbolization. In this case, a restaurant. Additional attributes are stored in a related table. This includes address components, cuisine type, in this case American, various name pronunciation fields, opening hours, phone number, and website. We created vector tiles of the full dataset for quick panning and scanning. Once again, I will zoom from global to specialized scale to show the increased rendering speed of the vector tiles. Note that the speed is greatly increased, but you cannot select features or view any attribution. I will demonstrate some of the capabilities of the Orbis data within ArcGIS Pro, starting with routing, which uses the Network Analyst extension. Currently on screen is a route, shown as a purple line, that was solved for a passenger vehicle which had to visit each of the stops 1 through 3. The green line represents the road network of Washington, D.C. The route solves for time, and so it shows the fastest route through all the stop points. The time needed for the vehicle to traverse a segment is calculated using an Orbis attribute called speed week, which represents the historical average speed along a road line for the whole week. And if we look in the directions pane on the right, we'll see the total time for the route is 44 minutes. This next route, shown in blue, uses the same stop points as the passenger vehicle, but this time is solving for a semi-trailer with standard US dimensions and a total weight of 30 tons. This vehicle faces additional restrictions that limit which roads it can travel on. Using Orbis logistics data, restricted roads have been identified as any with a maximum width of less than 8.5 feet, a maximum weight of less than 30 tons, or a maximum height of less than 13.5 feet. The directions pane shows that this route will take 51 minutes. Here we can see in more detail where the semi-trailer route, which is the blue line, deviates from the passenger vehicle route, the purple line. This is due to a width restriction represented by the red line here. This forces the truck to head north from this point. This last route, shown in orange, is again solving a route for a semi-trailer with the same dimensions, but with one additional restriction. It's hauling hazardous materials and therefore cannot travel on roads with a hazmat restriction. The travel time for this route is 1 hour and 14 minutes. Here we can see a hazmat restriction on this segment of road, represented by the yellow line. This caused a route deviation for the hazardous materials semi-trailer, shown as the orange line, in comparison to the standard semi-trailer, the blue line. Lastly, I will demonstrate a composite locator built in ArcGIS Pro using Orbis data. The composite locator is composed of 4 individual locators built from address points, geocoding lines, zip codes, and city boundaries. First, I will demonstrate a search by address, 4437 Wyndham Place. Next, we will search by street, For this example, Beecher Street Northwest. Next, we will search by zip code. This shows the centroid of the zip code boundary. And finally, search by city.
And that concluded the demonstration. So now I'm moving forward in the PowerPoint. There's just a few more slides. And what's showing up on screen right now is a map that we made here at East View recently, just in, I think it was in March. And this is a military style. Back in the day, it might have been called a topographic line map. It's no longer called that. It goes by new acronyms. But what it shows is that East View used the transportation layer and certain POI place names and transmission lines from Orbis. And then we conflated in some other information like geo names from GNDB and relief from SRTM. And then the schema for this was the topographic data standard 7.1 schema. So that none of that really kind of matters exactly. What does matter is that through different materials, Eastview or you at your particular company or entity, you need to create sometimes complicated graphics. And the Orbis Basemap anywhere in the world, when symbolized the way that we do, might be right out of the gates something that you can use to create the mapping that you need to create. Click. There we go. Two more maps to show you. These are far less than military spec maps. These are actually trade and travel maps. Over on the right is an original map, and we wanted to use Orbis for both this map and the next map, just to see if we need to make changes to tourist maps, which is one of our businesses, Eastview MapLink. We actually deal with trade and tourist maps. There again, how useful is Orbis out of the gates? And it is. Same here. This is diving in deeper into an inset of that particular map. And aesthetics aside, we're not really aimed at the cartographic aesthetics, although I do think the one on the left looks better. It's really the density of the information and the information that can be leveraged for updating of mapping data. So the next steps for you as a participant in this is ask questions now or later. You can request sample data. We'll provide sample data. We have sample data already to provide in a particular software version numbers, and we can share all the details of what that sample is ready to be used by. You can schedule a briefing or a demonstration with us and TomTom for your organization. So if there's a group of people that you want to see this and have a more interactive discussion versus us just, monologuing to you, please do that. And then finally, if you have an end use scenario in an area of interest that you already know you're trying to solve for, or you have an existing current state that you imagine a better future state, we can get into that as well. So Alyssa, any closing comments from you before we field any questions?
Nothing in particular, except for just thank you very much for the opportunity to talk about Orbis Maps. And I hope to dive into some questions, so don't be shy.
And if there are no further
yes.
questions, then please email me. I've got all of our contact information on this. And really appreciate the time and attention that was given to this. This is being recorded, and as I said, the PDF for this will be made available to the registrants of this webinar. All right.
Thank you, everyone.
Thank you.